Hello everyone, welcome back to my channel. I am the EE Guru, and today we'll be talking about current division. Also, if you guys haven't seen my previous videos on parallel circuits and Kirchhoff's current law, I would recommend you go watch that video now and then come back to this video, because a lot of the concepts covered in those videos applies to this video. So let's dive right on into it. So current division is a scenario where current divides between two parallel resistors. And this is an important point to highlight, that we can only use the current division equation when we have two resistors in parallel. So in this image right here, in this circuit right here, we have R1 and R2. These are two resistors in parallel. This is a node. We can use the current division equation within this scenario. If I was to add a third resistor in this circuit and call this R3, we would not be able to use the current division equation right away. We would have to do something like combining the equivalent resistance of R2 and R3 before we can use the current division equation. And also this idea of equivalent resistance, I haven't talked about that yet. I will talk about it in my later videos, so be ready for that. So we have two equations for current division. One allows us to solve for I1 and the other allows us to solve for I2. I1 is the current that is flowing through resistor 1. So I1 is right here. And I2 is the current that is flowing through resistor 2. I2 is right here also. IS is the total current that is coming from the voltage source. So this is IS right here. This is the total current. And if you've seen my previous video on Kirchhoff's current law, we know that the sum of current going into this node is equal to the sum of current leaving the node. So basically, IS is equal to I1 plus I2. This is the Kirchhoff's current law equation. Basically, the sum of current going into the node, which is IS, is equal to the sum of current leaving the node. So I1 and I2 are leaving the node. If you haven't seen my previous videos on Kirchhoff's current law, go watch that video now. So this is the equation for current division, and it allows us to solve for the values of I1 and I2 by simply plugging in the values for resistance of R1 and R2 and plugging in the value of IS, which is the total current flowing into the node. So that's the video. Next video, we will work on example problems to drive home the concept so you guys understand it a little more. So stay tuned.